Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 7th April 2023. The problem statement for today is add minimum characters. This problem is based on strings and data structures and this has been asked in Samsung interview. Let's now open this problem to solve it. Let's go through and understand the given problem. Given a string str, find the minimum characters to be added at the front of the string to make it palindrome. So again a simple problem statement. We have to find the minimum number of characters to be added in front of the given string so that the final added string becomes a palindrome. So let's go through the given examples to understand it in a better way. So if you take the input, here input is ABCD, then the output is 3. The resultant string after adding 3 characters is DCBABCD. That means ABCD is given. We are adding a reverse of this one, DCB. We are adding in front so that it becomes a palindrome. So 3 characters we are adding, that's why the output is 3. In the second example, here it is said that the given string is ABA. So it is already a palindrome. So that's why the output is 0. That means we do not have to add any string. Okay. So one way to solve this problem is to concatenate the given string with its reverse separated by a special character. Then find the longest palindrome that can be formed from this concatenated string. The minimum characters to be added in front of the given string to make it palindrome would be equal to the number of characters in the given string that are not the part of the longest palindrome. Okay, so for this one we will be using LPS, that is longest proper prefix suffix array. This array is the array which stores the length of the proper prefix which is also a suffix of the substring of the given string. Okay, so this array, that is LPS array, it will store the length of the longest proper prefix which is also a suffix for the given string. To find the minimum number of characters to be added in front of the given string to make it palindrome, we need to find the length of the longest palindrome that the string can be extended to. This can be done by finding the LPS array of the concatenated string, whereas the original string is concatenated with its reverse separated by a special character. So here we can use any special character, for example hash, and the LPS array gives us the length of the longest proper prefix of the concatenated string that is also a suffix of the same string. Okay, so when we get the length of the LPS array, we simply subtract it from the initial length of the string to get the minimum number of characters added. Okay, so let's understand this approach in a better way with few examples. So for that, let's move to this notepad here. So here, suppose we have been given this example that str contains ABCD. So what we do, we create a new string that is a concatenated string. What we do, we concatenate a hash, and after that we concatenate the reverse of this. That means the reverse of ABCD, that we do, and we concatenate these two. And from this one, we try to find the length of the LPS array. So what is the LPS array? LPS array is the length of the prefix that is also a suffix of the same string. So here we can see, if we see starting of this one, then for each character there is a one placeholder in this array. So here at last only we can see that A and A is matching here. A and A is matching. Only that is matching, because after A B is there, but after A nothing is there, because since it is in reverse, so it is ending here. So only one match is there. See, if you look at the subsequent characters, so you can say that even B is matching here. But first we need to cross A, then we can reach to B, and even in the same order it has to be there in the concatenated string. So that's why only A is matching here, and we do not have any further string. So where exactly it's matching? It's matching at the last index. That's why we are incrementing the value by 1. So here by incrementing the 1, what do we mean? We say that only one character is matching. So we need to append all the rest of the characters. That means how many characters? Out of these 4 characters, one is there. One is there. So we need to append 3. So if you look at this one A, and if you try to take a palindrome of it, so it will be here. I'll just write it here. It will be D D C B A B C D. D C B A. D C B A B C D. So one becomes a center point. That means from the left side or the right side, if you move, then one is the center point, and to the right of it, it is BCD, and to the left of it, it is BCD in the reverse order. So here we can say that taking this as a center point, we have to find the number of, we are appending the remaining characters. And how many characters we need to append, that we need to see that how many characters are we got in this LPS array at the last one. Okay, so this was for one matching. If we took, if we take another example, so here, if we take the example of Adam, so here, and if we perform the similar operation, that means we append hash, that is one special character, and we reverse Adam, and the reverses, that means the reverse string we are adding to the whole of it. So it becomes this is the concatenated reverse string. Okay, so it becomes this one. So if we look at this, then we are starting from A, and we try to see where the matching starts. So here we can see for the third, that means for index, if we start from 0, then for index 2 we got one match. That's why 1 is here. But after that, when we tried matching next character with M, that means D with M, so that match was not there. That's why we again we subtract the position of J. That means it again becomes 0, because we have to look for a continuous one. If we are getting the continuous one, then only we can say, yeah, that some part of the string is already there, and we need to just add a few. But if the match is not proper, that is not sequential, then we need to, in worst case, we may have to add the complete string again. So that's why, since this D and M is not matching, we are again not considering it and is making the 0 again. So, but when we move further, then we can see A matches with A here. So again the value incremented by 1 here from 0 to 1. So here one match is there. Then after that we increment both. Here we will be using 2 pointer I and J. So here we increment both. Then we see even D is matching here. So now we increment the value by again 1. So we can see 2 matches are there with A, D, and here A, D. When we move to the other one, so here A is again there. So here also it is matching here. So that's why it is incremented 3. So here it is saying 3 means 3 characters are matching. And this LPS array with 3, it is saying that there are 3 characters in the string, which is a prefix and a suffix. That means the 3 characters are there, which is acting as a prefix and a suffix in of the same string. Okay. So if we look at this, then we have one character. That means here the length of the character, length of this string is 4. So for among 4, we have already got 3 is already there. So how many characters we need to append? We need to append just one character. So the reverse of it will become, we will just add one character. What is that M character? Which is not matching. M is not matching. So we just add M here. So we add one character starting, then we append the given string. So it will become Madam. Okay. Out of these 4, 3 were already matching, so we completely discarded these 3. That's why I said initially, the minimum characters to be added to the front of the given string to make it palindrome would be equal to number of characters in the given string that are not the part of the longest palindrome. Here we are seeing the longest palindrome is 3 and M is not part of that. So that is the number of characters that we are adding. Okay. So similarly, if we go to the next example. So here in the given string is BAAA. So here if we again try the similar approach, then we can see only B is the character, this B is matching with the B of the last index. So we can again say only one character is matching, because after that A is there, but after this B nothing is there, it's the end of the string. So we can say only one is matching, so we need to append 4 minus 1, that means 3 characters. So again for this one, let me go back. Okay. here it was MADAM, then here it will be B A. Okay, so we have to append 3 characters here, excluding B. So what are the remaining 3 characters? It is A, then append the given string A B B A. So now even this has become palindrome. So I hope this is clear. So what we do, first we take a reverse of the string, then we add the hash, then we get a concatenated string, then we try to find the LPS array, and whatever the value length of the LPS array we get, we subtract it from the length of the original string. So that many characters we have to add. Okay, so this is the simple approach which we will follow to solve this problem. Okay, so with this approach only, see how exactly we do the calculation for the LPS array, that I'll explain it in a few minutes. So yeah, but these 3 steps we will be following. So with the same approach, I have prepared one solution. Let me just copy it here. So here again I have given comments against each line so that it becomes easy to understand. So if you look at this method, add minimum characters, then I have added 3 steps there. So in first step, what we do, we create a new string by concatenating the original string with its reverse and separating them with a special characters. So for that we are using string builder here. So using string builder, using reverse function, I am reversing it and then adding it to the str with a special character in between. Okay, then we call in step 2, we compute the LPS array of the concatenated string using the KMP algorithm. I'll explain it in just a while that what is KMP algorithm. So with this one we compute that LPS array and we get the LPS array value here. So what we do in the next step, in step 3, the minimum numbers character to be added at the front of the original string to make it a palindrome is equal to the length of the original string minus the value of the last index of the LPS array. Whatever we have seen in all these 3 examples, whatever we have got the last, so that minus that will be subtracted from the original length of the string, and those many characters we have to add. So that only we are doing here, that str.length minus LPS dot length of -1. Okay, so these are the 3 steps which we are using here to get the minimum number of characters to add it in the given string to make it as a palindrome. Okay, so here in this step what we are doing, we are computing the longest prefix suffix, that is LPS array, for the concatenation string using the KMP algorithm. So what is KMP algorithm? Actually KMP algorithm stands for Knuth-Morris-Pratt algorithm. That is a string searching algorithm that finds all the occurrences of the pattern string in a text string in a linear time, that is big of n plus m, where n is the length of the text string and m is the length of the pattern string. The algorithm pre-processes the pattern string to construct a partial match table, also known as the longest prefix, that is also a suffix table, which is then used to guide the matching process of the pattern against the text string. Okay, so what does the LPS table store? It stores for each position in the pattern string the length of the proper prefix, that is also a suffix of the substring ending at that position. A proper prefix is a prefix that is not equal to the entire string itself. A suffix is a suffix that is not equal to the entire string itself. The idea is to avoid the backtracking in the matching process by using the information stored in the LPS array to skip the already matched characters whenever mismatch occurs. Okay, so when we talk about this KMPS algorithm working, so it works by maintaining 2 pointer I and j that scans the text string and the pattern string respectively. At each step, if the current character of the text string matches with the current character of the pattern string, then both the pointers are advanced by 1 position. So here we are talking of this one. Here we are using pointer I and j. If the characters are matching at both the position, then we advance the value of both I and j pointer. If the current character of the string does not match with the current character of the pattern string, the algorithm consults the LPS table to determine the length of the longest proper prefix that is also a suffix of the substring ending with the previous position of the pattern string, then moves the J pointer accordingly. The matching process continues until either the entire string pattern entire pattern string is found in the text string, in which case match is reported, or the end of the string is reached in case the search of in which the case the search fails. Okay, so KMP algorithm is widely used in the many string related applications such as like text editors, compilers, bioinformatics, due to the linear time complexity and efficient use of memory. Okay, so here I'll just try explaining again with respect to this program how it is done. So when we are trying to compute this LPS array with this, when we pass this concatenated string, so first we are creating an array to store the LPS value for each prefix of the string. Then we initialize the pointers for traversing the string. Here we are starting with I is equal to 1, j is equal to 0, and till this condition holds true, that is I is less than the length of the string. Here the string is the concatenated string, not the original one. And here we check if I is equal to I plus, and that is if the character at I is equal to character at j. If the characters at the current position match, then we increment the value of I and j and store the length of the matching prefix and suffix. Okay, but if it doesn't match, see here only we are advancing the value of I and j also. We store the value in the LPS array and we increment the value, so that in the hope of finding next match subsequently. Here when we found this A and A matched, we incremented the value, but after that we found this D and M is not matching. So after that we had to take a different step. What is that different step? So here if it is not matching, then we see if the value if there is a non-zero LPS value from the previous position of j. Okay, then we update the value of LPS, then we update the value of j to the LPS value of the previous position of j. So in what was the previous position of j? Previous position of j was 0 in this case, where we were seeing this example here. Once we advance it, so j will become 1 and I became 3. But since this is not matching, we move back to the previous one, that means the starting of the string, because to find the characters which had to be appended, it has to be sequential. That's why we had to move at the beginning, and we need to find that what is the longest substring which we find which is present in this string as prefix and a suffix. Okay, so this was that one step here. And if even this is not correct, that if it is not equal to 0, then what we do, we simply update. If j is equal to 0, then the correct character does not match with the prefix and suffix, so store 0 and move to the next character. So till the point it holds true that the values are not matching, that means A compares to B, A compares to C, A compares to D, A compares to hash. So at each of these positions we are storing 0 till we find a match from this A and this A. In this case also, when we tried matching this A with all this position, we only found a match here, A with this A. So then we incremented it by 1, and for all other position it was 0 until it found A, D, A again. So here 3 letters was there, so in each step we got incremented by 3. Okay, so if it is not matching, then we are simply storing 0. Then at last we return the value of LPS here. So this algorithm, whatever we have used here inside this one, that is called KMP algorithm. Okay, so that value whatever we have got it here, so we look at the last index value. So whatever is the last index value, since it is 0 based indexing, we are doing -1 of it, and we subtract that value from the string of the length. Okay, so here str is the original string, not the concatenated one, because concatenated string name was concat_str. So from the original length we subtract the length whatever we have found as the substring which is already present in this one, in the concatenated string. So subtracting that one, we get the minimum number of characters to be appended to get the palindrome string. Okay, so I hope this algorithm, this approach, everything is clear. So let's try compiling this code. Okay, so again, the problem is that this is C++ editor, not the Java one. I need to copy it to Java editor. Control C. Oh shit. Okay, let me copy it from this file only. Control A, Control C. Pasting it here. This is Java again. Okay, now compile. Okay, so here we can see we have got correct outputs. Let's try submitting this solution. Okay, so here we can see it has covered all the test cases. So this problem has been solved successfully. So whatever the logic or the algorithm which we are using is absolutely fine. So talking about the time complexity of this one, it is in the order of big O of n, where n is the length of the given string. Since it involves only linear operations like string concatenation, string reversal, and computing the LPS array using KMP algorithm. Therefore, it should be sufficient for large inputs. Okay. So this was the Java code for it. Even I prepared a solution for C++. So let me just remove it, reset the code here, and I'll just try same. This is the same logic. I have just not included the comments here. So let me paste it here. Okay. So let's try compiling this code. Here also the logic is completely same. Only the syntax differences whatever we have between Java and C++ that is there. Let's try submitting this solution. So here we can see even with this the same code with in C++ language, even that is correct, and in this language also it has covered all the test cases. So I hope both the examples, that means all the examples and both the solutions in C++ and Java both would be clear to you. Okay, so I'll provide the link for this question in the description box, and along with that link for the solution, that means the code for it, even that will be there in the description box. So that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.